Good morning. My name is Sherry Reeves, and I'm the Executive Director for the Manufacturers Association of Central Florida, MACF. I'd like to welcome everybody today. It's Friday to Mitsubishi Power Virtual Plant Tour. I'm going to turn over the presentation to Michael. Good morning, Michael.
Good morning, Sherry. Going to share my screen here. Just let me know if you can see it. Okay, can you guys see the PowerPoint, Sherry?
I cannot at this point. I see welcome to the virtual plant tour.
Let's see here.
Now,
sorry, everybody. Were you guys able to see my screen?
We saw it for a minute, Michael, and then it went away.
Okay, here we go.
Technology.
All right, it says sharing screen now.
There it is.
There.
All right.
We can see it.
All right. Sorry about that, everybody. Good morning. My name is Michael Ryan. I work with Mitsubishi Power at the Orlando Service Center, or OSC. I've been with the company about 3 years now. I got my bachelor's in science industrial engines at UCF, go Knights, in 2017. And I've been with the company ever since. Feel free to ask questions during the chat. I'll try and get to them. If not, I will answer them at the end in the Q&A session. So welcome to Mitsubishi Power. Glad to be here presenting to you guys. And if you are excited and ready to learn about cars like this nice Mitsubishi Lancer down here, I'm sorry, but we do not make cars. We are Mitsubishi Power. So we are involved with power generation and other forms of power technology. So here we have pictures of an example of a power plant. So you can see each one of our gas turbines inside of the building here. Looks like there's about 7 here. And then inside that building are the gas turbines themselves. So these are what this is a picture of what the turbine looks like. And we manufacture individual components of those turbines. So what do you use power for? These days, it's just about everything. You have all this cool technology down here in your games, your PlayStation, Xbox, all of your home appliances like your refrigerators, your TVs, pretty much everything these days uses power. So we are much more involved in your everyday lives than just those cars that I showed earlier. So like I said, it's Mitsubishi Power. It is the same parent company as the car company, which is Mitsubishi Heavy Industries. We just fall in a different division. That's why you see the logo is the same. So here you see a picture of the gas turbine when it's all put together. And I'm going to tell you a little bit how our parts make power. So the first step is there's an air intake right here. And the air is going inside of the turbine. And as it travels through, that air is being compressed by these different compressor blades here. And that's increasing the pressure of the air that's flowing through. And then that pressurized air starts to mix in this combustion section. That's where all the different chemicals and the pressurized air combine. And what that does is it creates a gas. And what that gas does is it expands and creates that power generation and causes this whole rotor to turn and generate power. And those power obviously powers your local power plants. So at OSC, we have our imperative here. our imperative is to support customer needs by safely providing quality components as quickly and productively as possible. Environmental. We have a very involved safety team here that is awesome, and it makes sure that all of our employees go home in one piece, and they're very involved on the floor and making sure that that everybody is adhering to safety protocols. Number two, we have quality. So like it says in the imperative, we try and give quality products, and we have a great quality team here that has many different checkpoints throughout the manufacturing and repair processes, and to ensure that all of our parts are meeting the specifications necessary. Number three, we have on-time delivery. So our lead time for these parts are around 3 months, and we try to do our best to make sure that we start and finish a part within that time period. One of our biggest metrics here is on-time delivery, and just about every year we are at or very near to 100% on-time delivery. And number four here, that's where our team is going to get involved a lot. My team in the industrial engineering is cost improvement. So we try and have industry competitive costs. So that involves a lot of cost down. It involves a lot of efficiency increases on the manufacturing processes and things like that. So here are some pictures of the specific components that we work on here at OFC. As I mentioned earlier, we repair and manufacture some of these components for the gas turbines. The repair side deals with a little bit more components than the manufacturing side does. On the repair side, we repair vanes, blades, pieces of the combustion section, which involves combustion baskets, fuel nozzles, ring segments, and other pieces. So here you can see what the components look like after a few years in the gas turbine themselves, and then we repair them to be good as new. And then on the manufacturing side, we manufacture mostly vanes and blades that go on the turbine, and as well as compressor blades that we saw earlier that compresses that air to mix with the combustion section. So that is what the Orlando Service Center manufactures and repairs. The next part of the presentation is start talking to you about different areas.
Michael, are you still there? We might have lost Michael.
Yes, it looks like he's gotten frozen. So,
Michael, if you can hear us,
Michael?
you could probably refresh your browser. It might work to unfreeze you.
I wish I could give this part of the presentation.
I'll try calling him. We'll see if he can pick up.
Okay. Sorry, everyone, for this technical difficulty. We have any questions out there? We can at least maybe start having some questions when we get Michael back on. One thing I do know about Mitsubishi is they're very involved in the community. They've been a longstanding member of MACF, and they've actually had seats on our board and do a lot of community work. A lot of the young employees that they hire are students out of UCF, but a lot of people just think of manufacturing for engineering students. But a big company like Mitsubishi Power, they actually have HR. So if you're interested in HR, finance, they have a big department in finance, IT, all kinds of people that work on the back end of IT, safety, and sales, marketing. So a number of different positions that they offer within Mitsubishi. There's probably a little over 500 employees that work at this Orlando facility. And then they're headquartered in the Lake Mary office, where they have, again, probably a little over 500 people.
Hey, Sherry, can you hear me now?
Yes, we can hear you. And I was filling in and giving a little history about Mitsubishi.
Thank you guys so much. So could you, sorry about that, everybody. Can you fill me in? What was the last thing that you guys saw?
It was slide number 8, I believe.
Slide 8, okay.
Well, correct.
All right, I will start sharing my screen. Sorry about that again, everybody. All right, and if one of you guys could just let me know when you see my screen again.
We see it.
Okay, perfect. Sorry about that, everybody. So I'll kind of recap what I was talking about here. Our parts go through a coating process, which is just a kind of applying. So here what you see, what it looks like before and then after. This white material here is actually a thermal barrier coating. And the reason we have to coat all of our parts is because the inside of the turbine gets very hot, and this coating protects the parts from getting too damaged. And so I have a video here of what the coating process looks like, and I'll try to explain to you guys what you're looking at here. So here you see the metallic cobalt nickel coating. So this is a bond coating. So first we have to spray the part with a gun that allows the white coating there to adhere to the part. So we have two different coating styles for the bond coat, which is HVOF, high velocity oxygen fueling. And then here we have VPS, which is our second type of bond coating, which is vacuum plasma spraying. So operation just in different ways. And what they're doing, again, is applying that adhesive coating to the parts so that the white metal coating that you see here sticks to the part. And here's that APS top coating, atmosphere plasma spray. And it's spraying on, like I said, that thermal barrier coating, that white coating powder that protects the part from the hot turbines. And here your job opportunity as a clean operator, you can mostly learn from on-the-job training. Again, a lot of this coating is specialized to whatever components you're working on, so the best way to learn is through hands-on experience. Next here, we have a lot of different inspection operations and regular manufacturing operations. So like I said earlier, the quality is very important. So we have a lot of quality checkpoints and different quality processes. You can see CMM over here, which is coordinate measuring machine. So they're making sure that all of the holes, all of the sinking operations are in the right location. We have heat treatment up in these furnaces here at the top. And what those do is it relieves a lot of the pressure from welding that goes onto the parts. We have 3D scanning so that you can see any cracks or indications on the parts for the repair. And then CMM, I talked about that already. And again, on-the-job training. So a lot of what we do here, you can learn on the job by experience as an inspector or operator. A lot of what you'll see here is on our manufacturing side. This is the different machining processes here. I have another video, but we have multiple different machines, different manufacturing processes. We have mills, we have drillers, grinding. A specific type of machine manufacturing style is EDM, which stands for electronic discharging machine. And that's what you're going to see in this video here. So this is a Beaumont drilling machine. This is going to produce a lot of those holes that you're seeing in the airfoil of the part. I'm trying to move my mouse over it. And so here it's kind of hard to see, but you're seeing a brass electrode that's being fed through and is creating an electric current that is burning those holes into this metal. And that current is being traveled through that water that you're seeing sprayed everywhere. So this is one of the types of EDM machines. We also have EDM wires, which uses a wire that kind of cuts like a cheese grater, cuts off the thick chunks of metal. We have sinkers, which burns through oil, burns different shapes onto our parts. Down here, you see one of our mills that is milling into the combustion pieces here. So this job opportunity as a machinist, you can learn from a technical school, learn how to program and operate a lot of different CNC equipment.
So Michael, Anthony has, sorry, Anthony has a question. He said, how hot does the inside of the turbine get?
Good question. Austin, are you on? So I forgot to introduce Austin here. Austin is the Director of Strategic and Optimization at OSC. And his background is field service. So he has a lot of experience with the turbines out in the field. If he can jump in and answer that question for me, I would appreciate it. Austin, you there?
Yeah, hey guys. I am. I'm online. Unfortunately, I don't have the exact firing temperatures of the gas turbine. I'm gonna look this up here while you continue, and I'll have that answer here shortly. But essentially, the firing temperatures of the turbine have improved over time. So the temperature and pressure of the turbine continues to go up every year in terms of design cycles, and as a result, the higher temperature and pressure creates a better efficiency for the turbine. So as you can imagine, in this day and age of fuel consumption, efficiency is the name of the game. So as you can develop components and materials that withstand higher firing temperatures and higher pressures, then you're going to burn less fuel to make the same amount of electricity. So let me do some research on the exact firing temperatures of where we are today with the J machine, which is the most advanced machine we have, and then I'll get back to you when I'm ready.
All right,
thank you, Austin.
So we'll circle back to that in the Q&A session at the end. All right, good question. So the next career opportunity that we will be talking about is what I imagine a lot of you will be joining, is the engineering field. And we have multiple different types of engineers here at OSC. We have component engineers who are responsible for making sure that these parts are getting machined and manufactured and repaired in the correct way. We have the manufacturing engineers who are are responsible for the upkeep and making sure that the manufacturing equipment do what they're supposed to. So they program a lot of those EDM machines that we talked about earlier. They make the programs and adjustments to make sure that the machines are working on the part like they're supposed to. We have quality engineers, which is a branch of industrial engineering. The quality engineer makes sure that the parts come out the way they're supposed to by inspecting. We have certain criteria that they make sure that the parts are being adhered to. CAD engineering, which is really cool software that you can use to get a visual representation of what the part looks like. You can run simulations in there to make sure that the manufacturing processes are going to do what you want them to do. And then I have a slide later to talk about industrial engineering. But I wanted to show you guys a video here of one of our new processes that a component engineer was able to come up with. It is laser ablation. So what this is doing is we're using a laser now to clean the parts. And what we're doing right now is we're manually cleaning these parts. We're throwing them in a grit blaster, which is very time consuming. And as you can see, this cleaning process is taking a matter of seconds to clean that part. And it's going to help reduce cycle time. It's going to help ergonomics. So we're not going to have to be doing a lot of manual labor, just spraying manual labor. We'll just be using a laser to clean these parts. You can see how quickly that was. And our component engineers are always looking at different repair processes, different manufacturing processes that to make everybody's lives easier. So the job opportunity here, there's multiple different types of engineering, more than just what are listed here, such as aerospace, and you can learn all about those in college. And I'll go over some of the different colleges in the area later. So here is industrial engineering. This is kind of my bread and butter, the department that I work in. So that fourth imperative that we talked about earlier is cost reduction, making sure that we have parts run more efficiently. And another big portion of what we do is we take ideas from the frontline workers, because they're going to be the ones who know best about what they're doing on their day-to-day lives. So we want to hear from them. So one of the programs that we talk about is the Ideas program. And you can see over the course of our OSC history here, we've accumulated over 38,000 ideas that have come from frontline employees to improve our processes. And our job as industrial engineers is to take those ideas that come in and work with the operators and work with other teams to make sure those are getting implemented. So I have, so industrial engineer like myself, went to 4 years at UCF. So that's a job opportunity for college there. Here's an example of one of those great ideas that somebody submitted. So we have bolts here for the fuel nozzle portion of the turbine. And the way we clean them in order for reuse was to set them into a ultrasonic tank. But even after the ultrasonic tank was used, we were still having to hand wash these afterwards, which was taking about 2 to 10 minutes per bolt. And again, that's kind of an ergonomic need there, a lot of hand washing, a lot of stress onto the operator there. So the idea was to use a different cleaning substance called alloconox and washed off with water. So this was estimated to be about savings of about 4 minutes per bolt. And at first you see 4 minutes doesn't really sound like a lot, but it starts to add up when you start looking at how many times that operator is going to be cleaning bolts. So as industrial engineers, we start to do the math. So it's 192 bolts per set. Let's see if I can hide this here. 192 bolts per set at 4 minutes per bolt. So we're estimating about 12 hours per set. And then we are running about 14 of those sets per year. So that one small idea of just changing a little cleaning solution saved about 156 hours for the year. So that's why it's so important to listen to those ideas that our frontline workers have. So to summarize a lot of the careers in manufacturing that we've gone over, so we have engineering, industrial, mechanical, aerospace, chemical, field support service. That's a lot of Austin's background. So they work in the field on the turbines themselves to repair them on the spot. Blending, what they're doing there is they're blending a lot of that TVC, that protective coating, down to a certain thickness and smoothness. Welding, we talked about that, machining, and inspection. And a great way to get your foot in the door is to start interning early. So we've hired over 80 interns to full-time positions, and internships are the best way to not only get your foot in the door, but get a lot of hands-on experience, get a lot of a good reputation with the company that you're working for. And then when an opportunity comes up, you have a good chance of filling that position. I myself started as an intern at Mitsubishi Power, and then within 6 months, I received a full-time offer. So other essential departments that allow Orlando Service Center to do what we do, we have the EHS team, Environmental Health and Safety. We have IT, a lot of background workers that really allow us to do what we need to do. And job opportunities here, we have electrical engineers, programmers, IT, a lot of different ways you can go about getting into those fields, whether that be college, technical school, on-the-job training, a lot of different opportunities there. Some more of those, do we have another question?
Michael, hi, this is Sherry. Yeah, we did have a question from Robin. She actually has two questions. How many people were hired during 2020?
2020, we don't know the specific number, but we are continuously hiring interns. 2020 has been kind of a weird year here and everywhere really because of COVID-19. But that doesn't mean that we've stopped. My team specifically, we are hiring another intern who will be starting here shortly. I don't know the exact number, but a lot of constant hiring here, a lot of opportunities here.
Good.
Yeah. So good
Another question Robin asked was, what do you do with the parts and equipment that you do not use?
So are we talking about the repair process here that maybe they go out into the field or they come from the field and they're damaged to the point where we cannot repair them? So a lot of those we manufacture replacement parts. Does that answer the question, Robin? If you want to, I can't see the chat. I have the presentation open.
Let's see if
We'll keep going with the presentation, Robin. Go ahead.
Sure. Actually, the question was asked by Linda from East River High School. I apologize. Sorry about that.
Okay.
But yeah.
Linda, if that didn't answer your question, retype it and I'll start looking through it in the Q&A portion.
Yeah, let me interject, Michael. Typically, we do a pretty good job of reusing as much as we can. Turbine components, as you guys can probably imagine, are very, very expensive. And while the turbine does a good job of consuming itself, it consumes the blades that see the firing temperature, we're often able to bring them back to the repair shop, refurbish them, rehabilitate them, and get them back to running order. Now, that cycle will only last a few times, and then at some point there is an end of life to the material, at which point we call it scrap metal, and the scrap metal is returned and how do you say, recycled, I'll say, and then brought back to metal casting firms to repour metal.
Thank you, Austin.
Thank you, Austin. So here we have other careers in manufacturing that, again, support the specific operations side. We have remote monitoring, which is where we can see the process and the performance of the turbines out in the field. We have human resources, IT, which we talked a little bit about earlier, accounting, making sure that we're making money, not losing money, sales and marketing. They're really key on the manufacturing side to make sure that we're constantly having work. And then material planning and purchasing, making sure we have the everything that we need in order to manufacture and repair these parts. So how do you get into these careers? Well, the college, technical schools, certified training, Florida has a bunch to offer. We have some of the universities down there, UCF, UF, Florida State, those bowls down there in South Florida, Valencia, Seminole State College, Southern Technical College, and UTI, Universal Technical Institute. So Florida has a lot to offer in terms of these schools, technical schools, trainings, really good area to be in for manufacturing. Like I said, I went to UCF, and I went to just about each one of these schools and completed degrees there, and now in the manufacturing field. So I will exit out of the presentation, and Austin and I will start to answer those questions.
Yeah, if it's okay, let me get back to, I think Anthony had a question about the temperature inside the turbine. The latest technology we have right now brings our firing temperature up to 1600, which is a world record for firing temperatures in turbines. And that's equivalent to about 2,900 degrees Fahrenheit. I was trying to find an equivalent to so you guys could understand what 2,900 degrees Fahrenheit equates to, but I couldn't find that so quickly. But it's a exceedingly hot temperature for any material, coating, metal, or otherwise to withstand. So it's an impressive technology.
Thank you. I'm scrolling through here. We answered some of these.
Michael, if I can interject on some of the educational institutions. MACF, yes, as a regional association for manufacturers, we actually are very involved and have partnerships with Orange Technical College, Valencia College, and both of these technical colleges have manufacturing with welding and CNC and so forth like that. We also have Lake Tech in the area, and we have Lake Sumter College. So we have several of those. Obviously, there's also the through Florida Makes, which is our statewide representative. They have the Industrial Manufacturing Technician Apprenticeship Program. So again, through MACF, we have all these local technical colleges, as well as UCF. And as Michael mentioned, throughout the state, a lot of universities that offer higher education. So I'll let you answer the question, Michael, about, Franco just asked a question about a high school student.
So you mentioned in the job training, are there entry-level positions right out of high school that will allow you to work your way up? Definitely here at Mitsubishi, a lot of our blending operations, you can start at an entry level. And like I said, a lot of those fields that have on-the-job training, you have to go through any sort of technical as well as internships. A lot of internships start while you're going through school or technical school at the same time. That's another good way to get on the job experience. I wanted to go back, let's see here.
And something too, Michael, for the audience. Sorry. Go ahead.
Go ahead.
something else for the audience to make note is a lot of these certified programs, you can articulate and get credits and move on while you're working with a number of our manufacturers, including Mitsubishi.
Thank you, Sherry. I was just going to answer specific trade schools that are partnered with Mitsubishi. I'm not sure if we're partnered with them, but I know we do get a lot of people from Valencia that are going through their trade schools there. A lot of welders have come from Valencia. So I think I'm caught up with the questions. Any more questions, anybody? It could be about the turbines themselves, manufacturing processes, schools, anything.
I have a question, Michael. How long does it take you to repair a turbine?
It's a good question. Austin, can you help me out with that?
Yeah, so there's a couple different types of repairs, but having come from the field service industry, there are field repairs for the turbines. So the gas turbines have to be repaired in kind of a interval. So they're kind of a light repair, which happens every few hundred hours, and then there's a major inspection, which happens every few thousand hours. And the major inspection, I'll talk to that, takes about a month, about 4 weeks of around the clock field service labor to tear down and then reassemble and reignite the engine for use. So as you can imagine, 1 month of not generating power for the power plants becomes a very expensive venture for them. So we try to expedite as much as possible. We try to, correct our processes and improve our processes in order to reduce outage time as much as possible. The other minor inspections take anywhere from 1 to 2 weeks to do, and there's a little bit on a more frequent basis. But that's for the overall turbine. And then on the other hand, once the turbine's disassembled, parts come out of it, so blades and vanes. These are the parts that consume themselves because they're seeing the nearly 3,000 degree firing temperature. So they'll start to degrade and will need to be repaired. And when they are sent back to the shop, we're looking anywhere between 30 to 60 days, sometimes 90 days to repair the parts back to their operational condition.
All right, thank you, Austin. So I was actually scrolling the wrong way. I see more questions here. I see Canon asked, who are your main competitors? Our main competitors are GE and Siemens as far as the gas turbine and power generation industries. Robin wants to know how many internships we offer each year. It kind of varies year to year. I don't have an exact number, but there's always almost constantly internships being offered here. The starting pay, that's going to vary from depending on what you're doing. And yes, the majority of our internships are paid. Couple of questions about electronic cars and manufacturing. Again, guys, we don't manufacture the cars here. We manufacture the components of the gas turbines. So the same, you see those 3 diamonds. I know it's a little confusing, but same parent company, but we are in the power generation division of Mitsubishi.
Dave has some questions.
Okay, trying to scroll to see Dave. Which core soft skills are most problematic? Go ahead, Sherry.
No, you got it. Go ahead.
Which poor soft skills are most problematic, or which good soft skills are most desirable? So somebody that's easy to coach, somebody that's going to pick up things quickly is most desirable. From an engineering standpoint, we like a lot of familiarity with different kinds of softwares. Hope that answered your questions.
Dave, I would say in manufacturing, attitude. Attitude is very important, and showing up on time.
Yeah. Let's see here. We have from Akeem, what is the typical application and interview process for entry-level opportunities? So we have our HR team reach out and coordinate to set up interviews, and then what you're interviewing with for the entry-level positions. But if you're in manufacturing, a lot of the times you'll be interviewing with the supervisors or even the manufacturing managers there to make sure that you're the right fit for the job. On the engineering side, I'm involved in a lot of the interviews for the industrial engineering team. We like to interview, have a lot of the people that you'll be working with as the interviewers. Do you train in Lean and Six Sigma? That is a great question, Anthony. And that is something in the past we have done a lot in. And it's something that Austin and I specifically have been talking about recently, and getting a lot of our industrial engineers retrained on Lean and Six Sigma. And then that way we can go out and be kind of the advocates for Lean and Six Sigma to the rest of the shop. Good question.
Are there any other questions? Well, we got a new question, Michael.
Are you aware of North American Process Technology Alliance? I am not. Austin, are you, or Sherry, are you guys familiar with that?
I'm somewhat familiar with it.
Give Dave a couple of seconds, Dave. If not, I'll make a note to research it.
Is there
any other questions while Dave might be typing that out, guys?
Yeah. There's something specific about the NAFTA question.
Yeah. We'll let Dave elaborate. Could you repeat that, Austin?
Somebody asked about, I'm sorry? Somebody asked
giving Dave an opportunity here to elaborate on what specific,
Okay. Sounds like there's a little bit of a delay in the line, Michael, but somebody asked about competition as well. Our competitors consist of General Electric, Siemens, and those two have become the two main competitors for Mitsubishi.
Thank you, Dave. We got your website.
Dave put the link on the
Well, Michael and Austin,
guys?
Yeah, Franco's got one.
Can you talk a little about the outlook for manufacturing jobs in Central Florida, and why a student out of high school who is undecided would want to go this route? Austin, you want to handle that one?
I'm sorry, I missed this one. Can you talk a little bit about the outlook of manufacturing jobs in Central Florida? Yeah, so I think first of all, the economy has been a little rough for a lot of different industries, and as you guys know, like for instance, the entertainment industries, Disney, et cetera, restaurants are all peeling back and laying off employees, and so it's unfortunate. But the bright part about all this is that manufacturing, especially at Mitsubishi, has continued to be very strong, and this is partly due to the power generation industry, because you all use electricity. We're all consumers of electricity, and will continue to do so for the very long future, I'm sure. Yes, the outlook, I think, is bright for manufacturing jobs, especially at Mitsubishi and in Central Florida, and we hope to see some of you guys soon in this industry.
And I'd like to add to that, if I may, Austin. Manufacturing, not only here in Central Florida, but in statewide and national, is doing very well compared to other industries, especially those in the tourism industry. And this is an example of why America needs to manufacture. We had a problem with the PPE, and many of you know what that's about as students and adults, that we couldn't find face masks because many of them were made in China. So our manufacturers, if you're a consumer, they need to be manufacturing, whether it's our food, our cars, our cell phones, turbines like Mitsubishi. Products need to be made in America, and they are coming back. And we want to continue to grow our manufacturing industry so that we as consumers in America can purchase and maintain the products here in America. And besides, Americans make the best products in the world. We're number one.
That's right. Thank you, Sherry.
I see Dave.
Yeah, it's a good point, Dave. We actually have a lot of 3D printers on site here. What was that, Austin?
Yep, I was going to say exactly that.
Yep, a lot of 3D printers on site here. The people have been complaining about the masks and hurting their ears, so we've had people 3D print little, I wish I had mine here, but little bars on the back that take the stress off of your ears for the mask. We've had 3D printed door handles so that you're not using your hand to touch the door handle. You're kind of using your arms. A lot of spontaneous 3D printing ideas are going around there. What happens to manufacturing when regulations prohibit the use of fossil fuels?
So yeah, Michael, let me take
not
that
sure to
one.
answer that one. Austin, if you can jump in.
Yeah, so the prohibition of fossil fuels is certainly on the near horizon. I think most of us see that. But the good part about that, and especially with Mitsubishi, is we have kind of forecasted that. We've seen this coming many years ago, actually, and we have since developed our technology to be able to burn alternative fuels, so non-fossil fuels such as hydrogen. And so hydrogen is very abundant, as you guys know. It takes some energy, obviously, to produce it, and one of the means to produce it is through electrolysis in the solar industry, which we also manufacture for. And essentially, our turbines can now burn hydrogen. So we have a first, for this time it's dual fuel, natural gas and hydrogen, so a mixture of both. And that unit is being installed in Utah in the coming months and years. And the plan for that turbine and future turbines from Mitsubishi and other manufacturers really is to begin to burn 100% hydrogen as one of the fuels of the future.
Wow, that's pretty cool.
Yes, indeed, and it helps solidify the future of manufacturing because it's the same components, virtually the same technology will be employed to burn hydrogen, which means we get to continue to make blades and vanes for and turbine components for the foreseeable future.
Wow. Were there any other questions from the students? Well, Michael and Austin, again, great presentation, and I really appreciate both your time. I appreciate Mitsubishi allowing you to take the time to present to these students. Very important for them to understand that manufacturing is essential to our economy here in Central Florida, but also throughout our nation. I'd like to thank the teachers and the students and everyone else that got involved today. We want to show the students all the cool jobs that are in manufacturing. And as Michael said, if you don't want to be an engineer, that's okay, because there's lots of other jobs within our manufacturing facilities. And we're here to help you out. So again, visit our website at www.macf.biz. Mitsubishi, thank you for supporting us. And thank you for doing a great presentation this morning.
Thank you, guys. Michael,
thank you guys for having us. You guys have a good day.
Yep,
yes, have a great day.
Well.
And thanks again, everyone.
Thank you.